Hi all, welcome to Sidza.com. Here in this video we will learn about the percentage. For a particular solution, there are different ways of expressing the concentration of it. There are different ways by which we can express the concentration of the solution. Like we have molarity, normality, mole fraction, mass fraction, and ppm, parts per million. There are different ways of expressing the concentration of a solution, but right now in this video we will learn about the percentage. We can also express the concentration of a solution in terms of percentage, and percentage we express generally in three different ways. Either it will be the weight percentage, means weight by weight, volume percentage, or it can be the mass by volume percentage. First, let's look at the mass percentage. Mass percentage, it represents the mass of a solute present in 100 grams of solution. So if you have, a solution, and what amount of solute is there, how many grams of suppose solute is there in 100 grams of solution, and that is called as the mass percent, right? That's the percentage by mass, right? We can also call it as a percentage by mass. So percentage by mass means the mass of solute divided by the mass of solution times 100. This is how we calculate it. Let's take an example. Suppose if I add 30 grams of solute, right, in 70 grams of the solvent. So we got here the 70 grams of solvent. Now when I mix 30 grams of the solute in 70 grams of a solvent, what will be the percentage by weight here? Right? What will be the percentage by mass? So the percentage by mass, right, of this solution will be equal to weight of solute, which is 30 grams. Mass of solute, it is 30 grams, divided by weight of a solution. Solution means the total weight, right? So solution is basically the weight of solution will be the weight of solute plus weight of solvent. So it is 30 plus 70 times 100. Right? So it will be 30 by 100 times 100. It is actually now 30%. Right? So this is the percentage of the solution by weight. Okay? Let's take here another example. Calculate the mass of the glucose required to prepare 250 grams of 30% aqueous solution. So we have to find the weight of solute. We have to find the weight of glucose. Suppose we want to make an aqueous solution of the glucose, and its percentage should be 30%. We have to find the weight of solute. How many grams I should take and how much of solvent I should take, how much of water I should take. Okay, so I'm going to use the same equation here. The mass of percentage equals mass of solute. So I'm going to same equation. Mass percent will be equal to weight of solute by weight of solution times 100. Okay, so mass percent equals weight of solute. Okay, weight of solute divided by the weight of solution. Weight of solution times 100. If you look at here, percentage we know we have to prepare 30%. Okay, we need a 30% solution, so it will be equal to weight of solute. That's what we need to find. So weight of solute by weight of solution is 250 grams. Total weight is 250 grams into 1000 times 100. Correct? So it will be the weight of solute here will be 30 times 250 by 100. Okay, so we can cancel out these two, so it will be now a 75 grams, right? Which means that we have to take 75 grams of glucose. Okay, we have to mix 75 grams of glucose with how much of solvent? What should be the water? Okay, total weight of the solution is 250 grams, and out of the 250 grams the weight is weight by glucose is 75, so now it will be 175 grams, right? So that means to prepare a 250 grams of 30% aqueous solution of glucose, I have to take 75 grams of the glucose and mix it with 175 grams of the water, and I'll get 30% weight, 30% solution of glucose. Now look at this question. If 250 grams of the 30% aqueous solution of glucose, it is the same solution that we have prepared, right? We actually got a 250 grams of, we have a 250 grams of aqueous solution of glucose, okay, and its percentage is 30%, right? It is 30%. We're going to dilute it. It was diluted by 50 grams of water. That means we are adding some more water here. We are adding 50 grams of water. Correct? What is the final percentage of the solution? Okay, we have to find the weight by weight percentage. Weight by weight percentage of the solution. So we will do the same thing. We will first calculate actually. We can calculate here the weight of solute and the weight of solvent, which is there in this 250 grams. We have just calculated that 250 grams of the 30% glucose solution contains 75 grams of glucose, okay, and it contains 175 grams of water, isn't it? So this is the glucose, this is the solute here, and this is the solvent, 175 grams. Now when I mix 50 grams of water in it, so now the total weight of the water, weight of the solvent will be 225 grams, right? So that means we can now find the percentage, right? So we can say the mass percent of the solution will be equal to weight of solute. How much is the solute? It is 75 grams, right? 75 by 225 plus 75, right? Isn't it? This is the total weight of solution, correct? Times 100, right? So it will be 75 by 300 times 100, so it will be 25%, okay? So the solution has a percentage of 25. So that means it has been diluted actually by 5%, correct? By adding 50 grams of water, the solution got diluted by 5% here. Initially its percentage was 30%, now it is percentage is 25%. So dilution decreases the concentration of a solution. Another way of expressing the the percentage is the volume percent. That means if you take solute here, not in grams, but you take in mLs, right? So we take the volumes of the solution, solute here, okay? So if you take the solute in mLs, in liters, right, and you express the volume of the solvent, you take the solvent also in volumes, right? See, for example, I'm going to mix here 20 mLs of solute is mixed with, say for example, it is 60 ml of water, correct? 60 ml of the water. So now what will be the volume percentage? The volume percentage will be the volume of the solute divided by the volume of solution times 100. Pretty simple. So we can say the volume percentage will be equal to volume of solute. Here the volume of solute is 20 ml. We actually are taking 20 ml of solute and mixing it with 60 ml of the solvent. So that means the total volume of the solution will be 20 plus 60, which is actually 80. Now time is 100, correct? Because this gives us the total volume of the solution. So it will be 20 by 80 times 100, okay? So it will be 25%, right? So this is the percentage per volume. So when you express both solute and the solvent in mLs, right? So volume percentage means how many mLs of solute are actually present in 100 mLs of the solution, right? So hope you got this one. Now let's move to the next one. We can also express the percentage by mass by volume. Okay, so you can say weight by volume. What does it mean? It actually means how many grams, right? You can say how many grams of solute is present in 100 ml of solution, right? So if you got 100 ml of a solution, how much of solute is there in grams? So when you take solute in grams, right? You take solute in grams, and in 100 ml of the solution, what amount of solute is there in 100 grams of solution? That's called as the mass by volume percentage. And how do we calculate it? We calculate it by taking the mass of the solute here divided by the volume of solution. This is, remember, this is not the volume of solvent, this is the volume of solution, total solution. That means the volume of solute plus solvent, correct? Say for example here, if you are taking we have an aqueous solution of sodium hydroxide. Okay, so for example we got an aqueous solution of sodium hydroxide which contains 3 grams of solute in 50 ml of solution. So if we have a total volume of solution is 50 ml and it contains 3 grams of solute, so what will be the mass by volume percentage? So we can say here the mass by volume percentage will be 3 grams of solute here divided by 50 ml of solution times 100. So it will be 30 by 5, which is 6% percentage by weight by volume. Okay. Now what about the strength? What is strength? Strength is, it represents the mass of solute in grams, right? So weight of solute in grams present in 1 liter of solution. That means strength basically represents the number of grams of solute present in 1 liter of solution. Okay, in 1 liter of solution, how many grams of solute are there? That is what we call as a strength. Say for example, we are mixing here 20 grams of solute in 250 ml of solution, 250 ml of aqueous solution, right? So we have a solution, 250 ml aqueous solution, that contains 20 grams of solute. So 20 grams of solute is present in 250 ml of aqueous solution. What will be the strength? As I said, strength represents the weight of solute in grams present in 1 liter of solution. That means mathematically we can say strength will be equal to, that will be the weight of solute, okay, weight of solute divided by the volume of solution, right? Volume of solution, but that will be in the liters, correct? Volume of solution in liters. Or I can slightly modify it, I can say it is weight of solute time is 1000, the volume of solution in mLs. When I change liters into mLs, I need to multiply it by 1000, right? So now I can use the same equation here. Weight of solute here is how much? 20 grams time is 1000 divided by volume of solution in mLs, right? See, here it is volume of solution in liters, but now I'm going to take it in mLs. So it is 250 mLs. So when you solve it, here is 1, this is 4, this will be 80 grams per liter, right? That means the strength of the solution is 80 grams per liter. No doubt we are mixing 20 grams of solute in 250 ml. So when 20 grams are present in 250, you can say this is strength will be 80 grams per liter, correct? Hope you got the concept. Thanks for watching the video. Bye for now.